Hey everybody, Dave Lindberg, THD Podcast again. This week we've got a special guest coming all the way from the Netherlands, Bouwy Van Sambeek, and of course Simon, as always, in Japan. But Bouwy runs a company over there called JackSavior, and we've known each other for coming on a couple of years now. And so I wanted to bring Bouwy on the podcast here to introduce his technology. So, Bouwy, please tell us a bit about yourself and where you're from here.
Yeah, hello. So my name is Bouwy from the Netherlands, Bouwy Van Sambeek in Dutch, and I live in Rotterdam. I work in Delft. I studied in Delft. There's a technical university there, the Technical University of Delft, and a lot of people might not know that, but it's a big university. And my background is that I studied mechanical engineering, a bachelor, and then in the master, I tried to explore a little bit of entrepreneurship, and I found out that it's quite fun to be an entrepreneur and gave me energy. So we were looking around, and I'm not sure which year it was, but the first and the second iPod was released. So it's a
Wow.
long time ago. It was like this big brick,
Yeah.
and a friend of mine broke his jack inside his iPhone, and that happened like one year and 1 day, so just after the warranty. And he was he was not amused. So we started thinking about what happened here, and that's how we discovered the problem of what we're trying to solve with JackSavior.
Okay. So the problem is in general, it's just the weaknesses of how analog jacks for audio are assembled. So maybe we could go through a bit on so you've taken a different approach to the assembly process and just maybe tell people about that a bit.
Yeah, so should I switch to my slides and just
Yeah.
start from there?
Yeah, let's do it. Let's show
So,
people some pictures.
so let me get the presentation up, and there we go. And so um, let me circle back to this in the end. So the problem that we discovered with the big iPhone is that we had the soldering connection that breaks. We have the internal jack that breaks in the device. Like everybody, or not everybody, has maybe a phone where they break off their jack. But sometimes it also just breaks if you have a headset, and it just breaks here,
Hmm.
right outside of your device. And to be honest, I just think it's old and chunky design. It
Right.
comes from 1876, invented by THD Podcast for the connecting of phones, and
Where was he from?
Hungarian. Is an
Okay.
Hungarian guy.
Okay.
It's
Cool.
uh, it's pretty cool. They have a lot of documentation on how he did it and what he did. He's just basically an entrepreneur that heard about the invention of the telephone, and then he just rushed over and said, "What do you need?" And it's like, "Yeah, we need to connect all the phones." And then he was the inventor of the switchboard, and also the connection jack, which, to be honest, is genius, right? They just recently switched back with USB-C to a port that you can plug in anyway, anyhow. And so it's a genius concept, in my opinion. But I'm biased because I am in the plug business.
Cool.
So what the market did is that the market made it smaller, cornered, and magnetic. And magnetic, you don't see that in the market, but there are a lot of patents on that.
Okay.
Um, so what we did is that we connected the wires on the inside of the plug, and we soldered them inside. So the outside is completely, it's only the cable, so it's completely flexible. Whereas the old connector, you have the connector, they solder the wires to it, then they overmold that with PP or ABS, any hard plastic, to protect the soldering connection. And sometimes they make a knot just for the pulling and extracting, make sure that the soldering joint is not forces are not extracted on it. And so by connecting it inside, we remove the moment and the forces that act on the outer part, because all is flexible. So just to demonstrate that, is that I'm not sure if you're going to use this image, Dave, here, but it's
Yeah, we can
just
see you.
Yeah, it's completely flexible. This is a very small plug. We also have the 6.3. It's a little bit bigger for the camera. So then it's completely flexible. Whereas if you would take like a standard Roland cable, then you don't have that flexibility because it's all big.
Right.
Again, an old chunky design. So in terms of performance, we see that it's 10 times stronger. It's we have we cannot say 100%, but 99% radio frequency interference rejection because of the connection goes inside the connector, and the connector goes inside the device, which is shielded. So that's a big plus for microphones, and it's just more comfortable. It's smaller. It's more flexible. And what we see now is that when people come in contact with the JackSavior, they have a JackSavior connector, then you realize, oh, all the other plugs are really old and chunky, and I don't want that anymore.
Yeah, so I think like in the days of the telephone mixing desk, that's one thing where things were large, but as mobile phones and then even body packs for broadcasting or MI type applications, those little body packs keep getting smaller. Phones get smaller and smaller. So you can just see how the jack and then how it interfaces with people like maybe listening to headphones out of their pocket. I mean, terrible abuse or body packs, people on stage performance, jumping around and really uh, doing a lot of damage to those traditional jacks. So I guess the theme here is just the durability is like outstanding compared to traditional.
Yeah, so we were together at the NAMM show, right? And we were looking at the Sennheiser body packs,
Yeah,
where the
exactly.
connector now is almost just as big as the body pack itself.
Right, right.
And that's partly also because so they have the problem that the connector breaks, which I'm familiar with, and then they engineer it in a way that they can open up it again and then they can resolder it. So that's why it's also very big. But it's, in my opinion, that's a little bit Then why not make it durable in the first place, right?
Right, right.
But
So is it
So can we talk a little bit about some of the mechanical details, the internal? So I have a bit of experience with 3.5mm jacks, and you have a pen, and then you sleeve an insulator on sleeve, another tube on that sleeve, an insulator sleeve, another tube, and so on. And then you have them stacked out the top and solder onto there. So you must have completely developed a whole new manufacturing process for that part too, then.
yeah, yeah. So all the sleeves, we have rings that are connected to the wires, and then they're overmolded. And during the overmolding and also during the assembly phase, we some of the cable goes inside those rings, and making like the knots that they normally use for pulling. That's not strong.
Do you have to solder to some of the parts before it's stacked?
Yeah.
You do. And how do you actually go about prototyping or developing something like that? I can imagine, because the tolerance requirement's so high. How do you even prototype something?
That's very difficult. So we have some time, right? So let me go from the beginning. Is that when we started, 3D printing was just started, and our design was like a cartridge. We first started not with soldering, but with a press fit connection, which is a lot better. Maybe you can just stop here slides.
Yeah, you can turn off. There you go.
Yeah, so we started with a press fit connection. We had like a small cartridge, we called it, like a small plastic part where you pre-assemble the wires on, and then you put the rings on. And we had the rings made at a shop here in Delft, and they
Is it
were
made by CNC, or did somebody actually draw these parts?
No, CNC, which is terrible, because then the tolerances are higher than if you would do extrusion or stamping, which you eventually have to go to stamping to get to the desired tolerances. So you're spot on that technical point. So what happened was with the first rings is that we just press it on, and then it would scrape a little bit of the 3D printed part off if it was bigger or smaller, depending on the tolerances. And
Right.
also is that we also had some designs where we just left a lot of space, and then that would be filled up during the injection molding phase. But then you would have loose parts in your tooling, which they don't like.
Right.
But that was good enough to sort of prove the concept then and move on to actual.
So on the whole development stage, we then flew over to Hong Kong because that's apparently the place to be. And then we talked to the Woox Innovations, which was then Gibson Innovations, which are doing the Philips brands, for example, and the JBL, not JBL, that's Harman. And they introduced us to their supplier, and they Minami Acoustics, and they were very. They took me into their family, and I've stayed there for like, I think in 3 years' time I flew back and forth 19 times, something like that. And they helped me with finding suppliers for CNCing the rings that made it a little bit better, and that sort of stuff. So we still did prototyping with CNC. We still do a little bit of CNC, and we're almost at the point where we can do a stamping order, because then the volumes are higher, and that makes, on the other side, the manufacturability a lot better. So so that's the whole story of how we do that, how we manage that tolerance. And then the biggest problem with that is not on the inside, but more on the outside, closing the tooling on those rings, making sure it doesn't flash. So that flash is the PP flowing over the outside of the ring between the tooling and the ring, and then you don't have any contact. So that's a very important part.
Okay.
If you do a 3-pole connector or a 4-pole connector, is there a big difference in technical difficulty?
The cable has a bigger impact. If you have like very thick cables, then your space inside gets smaller. So there's 2 millimeters space inside our rings. So that gives maybe an idea about how to work with that. And if you take a normal headphone, so this is like a standard headphone that we made, and it's outer diameter 2 millimeters. 2 or 2.5 is quite standard. And normally they have like 4 wires in them, or 6 wires, and you can fit that inside the 2 mm. That's not a problem.
So it's literally like threading a needle, just like a multi-threaded needle, depending on how many pins. So that's it's quite challenging. So then I guess, like, obviously the cable connector is a very mature thing. I think 18 something you said it started, and I think you and I together have seen some production facilities where they're churning out millions of these things. It would sound like your process takes a little bit longer to do, produces a better product in the end, but kind of what techniques can you see to get your volume up in a production application? Like, what are you guys looking at to accomplish, like, meeting the goals of high volume or higher volume production?
Yeah, so maybe I can show you how we do it now, and then maybe can talk a little bit about the future. So let me share my screen here. So also regarding the soldering, you guys see this, right?
Yeah.
So this is an old fixture that we have made to assist the Chinese in soldering the wires. So what happens is that if you use the pedal on the ground or a button, then it will start. You have to put the ring inside the block in the middle, where you see the needle going, where the soldering tin is going, and then it puts down a soldering droplet that is very accurate. And normally in a normal factory they would do that by hand, or they would have a very big soldering iron, which also takes away or adds a little bit more or any debris or anything to the droplet. So getting that accurate and very small is very important to reduce the size, or to work with the size that we have. Right. So and then this is semi-automatic. So what the worker does is that they put the ring down, then the soldering droplet is added, and then the worker has to add the pre-tint wire into the ring, just to soak it up into the bubble of the soldering. And this enables any worker to solder a JackSavior adapter, compared to normally where they need to have a soldering worker, or a worker that is capable of doing good soldering. So that's one of the things that the factories really like. And then, so this is the current process, and then we have the overmolding, and we have the following steps. If I explain to them how to do it, then it looks like this. So we do workshops, and then we explain, hey, this is how we have to do it. I bring some rings, and we have a good afternoon of soldering, and everybody is laughing and trying it out in turns, which is pretty fun always. My Chinese is not that good, but with engineers, it's very easy to communicate with. If you have a whiteboard and a black marker, then you can do anything. So they like it. I hear another one of my colleagues explaining. We gotta. What you see here is also we have some different devices for different rings. So you can imagine that for a bigger ring you need some more power, but also for the tip part, which is our tip part is almost the same as the normal part, and we have some other devices and other methods for that. We also use resistive soldering, which is also very common in these kind of factories.
What's resistive soldering?
Yeah, resistive soldering is very, very, very interesting. Resistive soldering is it's a graphite pen, special graphite pen, and then they put through 3 volts, 20, 50 amps, and then if you have the graphite pencil, then and you have the contact point on your material, then the point is the smallest part, so that will heat up instantly and become red hot, and then you can solder. But at the moment that you release the graphite pen, it becomes cold instantly almost. So you can really rapidly solder if you have the skill to do it. It's a little bit tricky, and also the graphite is a little bit tricky, because if you take, for example, a normal pencil, that's also graphite, but that's combined with glue, which can explode in these kind of situations. So you need a little bit different composition of the graphite, but it's awesome, and it's really quick, and it's no heat up time. So you can just, if you don't use it, it's okay. So it has a lot of advantages, but you have also some degradation of the tip, which is a little bit quicker than with normal soldering. So depends, but normally they have like a small Hello Kitty pencil sharpener next to it, and they're good to go. So
it's I don't want to cut you off, but it sounds like where we're leading to is that the automation and better technique in soldering is what makes you competitive to like the traditional kind of basic connector in terms of volume production.
Yeah. So Dave, we went to Fujigan, right? The last time we were together in Dongguan, and there we studied, or we've seen how they do it now, and
right.
And there you see that they are struggling with the semi-automation, right? They're trying to automate some stuff because they want to have a more stable production line. They want to have a high yield of the production, and they want to keep that stable, and also on the other hand reduce the dependency on high educated workers. So they don't want to be dependent on soldering skills and that sort of stuff.
Right.
So where was I going with the story is that that's why they like the JackSavior automatic machine, and we try to also use that trend to help ourselves with the process. So, and then if you do you want to add anything here, or can I go to the future?
We're waiting on your story about where the future lies.
Yeah. So the future is very difficult in the sense that you have we are now at a point where we can stable produce JackSavior connectors in a small factory. And here's the big difference. You've got small factories, medium factories, and big factories, and they all have their own skill set or dependability. So we were at the factory here where this is a small factory, high volume, very high volume, low quality. But these factories require, they really like just handwork or fully automatic, not semi-automatic. They don't want to fuss around with that kind of stuff. But with the Fujikon factory, they do all kind of steps in between. Which Fujikon is a big factory, and they want to use fixtures, semi-automatic or full automatic. But most of these factories understand that they don't want to invest in any full automatic machines. They calculate the risk and how they get it back. And normally they don't have enough. Or what I've seen is that they're understaffed in machine or people that make machines, mechatronics. So they don't like to add too much of these machines. Okay. So what we've seen is it, let me check where I can find this video here.
Oh yeah.
I'm not sure if the audio comes through, but audio is not that important.
Oh,
so what we see here is what you were explaining with the rings and the sleeves. So this is the process of the normal connector. And here in this blue box, there are all these small rings or one type of rings. And what she's doing is that she's pouring with some kind of technique with her hands those rings over a fixture, which place them all in the same orientation, in the same stuff. And let me do it again. So she's pouring it over, then she just does something, and then there are all these tubes are aligned perfectly. And we tried to do it ourselves. I think Dave, you tried it too, right? Or
Thomas definitely invested some time trying to get it right.
And this is so funny, is that you see in the factories that people do this, and it looks so easy, but this is a complex step. It's and it's also a lot of time it's female who does it because they are, I think, better somehow. But so I'm getting puzzled by the process again if I look at this too much. So if we talk about future, that our process is different. So we have to, what you said, we have to get the wires like thread through it with a needle or in that phase. So we are doing some development on pushing those wires through with air and those kind of stuff, and not with this technique, with this fixture technique, because we have the wires already attached to them, which makes this impossible. So in terms of future, we see a lot of possibilities to improve the process, but again, we are looking at improving it for smaller factories and improving it for like medium factories and big factories, which are two definitely different routes in what we can develop and how much money we can spend on parts. Until now, we've tried to make it as that simple as possible, just to make the factory able to how do you say, to, if something breaks, then they can buy the parts themselves. They know all the parts that we use because we ship them, we buy them in China, we get them here in the Netherlands, and we make the machines with the same parts they are used to with working with. When we are at factories, we also do a tour normally at their mechatronics department or like spare parts place where we can see what kind of stuff they're using, what kind of heaters, what kind of controllers, just to make sure that we use exactly the same so that they're not dependent on some small company in the Netherlands.
Okay, yeah, no, that's.
And so the model is, sorry, Dave, the model is licensing the technology, or you get factories to build it and then sell the products?
Dave, or should I answer?
You go ahead. Let's stop the screen share right now so we can see everybody.
Yeah. So the business model is a license model. So if you, for example, would like the JackSavior in your product, then you contact Dave or you contact me, and then we look at okay, what do you want to do? What's your application? What kind of plug do you need? And then there are basically two routes that we can do. One, we can do an RFQ, a request for quotation, at our partners that can already do the manufacturing, or the second step is implementation at their preferred supplier. And when we do that, then we need to go there and explain how to use the JackSavior machine. It's optional. If they think they're very good at soldering within 2 millimeters and getting small droplets, accurate, the same droplets every time, then they can do it themselves. It's not obligatory to use us, but it's definitely recommended. And then we have the license that we can run through the factory on the BOM, on the bill of material, or a direct license. And what we also see is that some of the customers just they like, how do you say, they just want to like be carefree, and we can just sell them a box of cables. That's also possible, to make it simple.
Okay, so
and we do all the sourcing and that sort of stuff.
Right. So yeah, I think it kind of makes sense to me now about how like it seems like, and you correct me if I'm wrong, but the vision is you kind of start with this initial model, but you could see that I think the automation concept of what you're bringing on could be like for everybody doing cable connectors in the future, as you expand the process and eliminate people, so to speak, in the process when they're ready. So it's kind of like you got your feet wet on mastering the automation process at this stage, but this has like potentially great future in terms of like everybody going automated for cable and assembly.
I'm not sure if the cable assembly will be fully automatic in the near future, because let's go into the technical details. So you have like the cable, you strip the cable, and then what they do is they tin it. So they push the cable into a tin bath, and then you have like the small part. But what you have is that you have the tin part, you have a heat affected zone, and then you have the cable. And this makes that the cable goes in any direction every time, every differently. So it's very difficult to have a machine do the soldering. So I've studied many USB automatic soldering machines, there are a lot of, like the USB-A, the normal one. But those pads are really, the spacing between the pads is really big. And USB-A connector is really big. So what they do is that they take the wires, they hold them in place and two places. So a worker actually has to put in the cable, then the machine strips it, tins it, and then they solder it to the pad, and then they remove the cable. But that's all. The first steps are all where the cable is held like this. You cannot have a cable only on one side, because then it goes all the way. You cannot fixate it. So it makes sometimes more sense to just do, in my opinion, do it semi-automatic, where the worker who has eyes and hands can orient the cable in the right way to put it exactly where it needs to go. So what we've seen at Fujicon is that they do the same things, that they automate almost everything except for that part.
Right.
So there's still one worker that has the tinned cable, and they put it into the soldering droplet. But the soldering droplet and the soldering iron is all done automatically.
Okay, yeah, you kind of touched on that earlier now, I guess, in terms of the degree of automation that factories want to take on. There's a risk to it, and maybe it's just easier to throw somebody to do that. I mean, you got to imagine it's got to be pretty high return to make something 100% automated, because like you talk about these minutia details of the assembly, and to get a robot to be precise is what you're talking about, where a human can just do it quite simply. I guess that's the trade-off. So maybe not in the near future, yeah.
Or you have to accept a lower yield of the production. And
Right.
but that it also means that you have to do more quality control. But that you can automate that, of course. So all the headphones that you get for free in the airplanes, in
Yeah.
airplanes, for example, those are pretty much automated, fully automated stuff. I've been to those factories too, but that quality is a lot different than what the A brands, the high brands require. So that's it's a little bit, yeah. So that's the trade-off, definitely.
Okay. So yeah, that's you mentioned brands there, so that's a good segue into. So I know 18 string is kind of the lead customer on this, and that's I mean they're a company that does a connector for violin, for the pickup of violin. Is there any other kind of applications that 18 string is using it for today, and any other brands that are on the horizon that you can mention?
Um, yeah, so maybe I can show some pictures on
Yeah, sure.
what we are trying to do now. So let me share this um, this one. So here I got like one slide. So the first project was Eastman Strings, where they made an electric violin, where the pickup is integrated into the endpoint, and they discovered that they would like to have the smallest connector possible, and that's how they find us. And we made, I think, a beautiful cable with the smallest cornered plug out there. So if you buy an Eastman violin, then you an electric violin, you get that. And the funny thing with this project was that they are normally they how do you say it, in the music industry they all use quarter inch, right?
Okay.
So it's very uncommon to use 3.5 for pickups and that sort of stuff. Definitely with guitars, everything is quarter inch. And with the violin, of course, it's a smaller thing. But a lot of electric violins still use quarter inch, and they also use like these kind of like, how do you say it? Just like big cables. I think the outer diameter of cables of like 8 mm. And so what we heard when we launched when Eastman Strings launched this guitar was that the weight on the shoulder of the cable alone was such a relief in comfort, and so comfortable that people really liked it, the violin, for that. It's added a lot of more comfort to it. The cables, the guitar cables, are quite heavy. The connectors are heavy. The cables are heavy, and so what we've done with that feedback is that's the picture on the right, our own instrument cable. Of course, we had to switch to the quarter inch because a lot of the guitars are quarter inch, but it's a very lightweight cable that offers the same durability and performance. But it's just lightweight. So all the when we were at the NAM and we gave this cable away to artists that were playing like electric violins, or like smaller guitars, ukuleles, that sort of stuff,
Hmm.
they liked it just because the weight. They didn't have the weight of the cable pulling them down.
Right.
So that was a funny feedback point that we didn't know beforehand. And also just with the guitars, that this because it's smaller, the stress relief, they just like it, and they said it's a good sound. But I'm not. I'm a soldering technology guy. I'm not a guitar player, so I'm for me it's
But
very difficult to say something about how it sounds, the cable
yeah,
sounds.
and if you remember at the NAM show, we there was a story about the cable technician in Los Angeles that they had like literally a mountain of cable somewhere in their warehouse that, oh, we'll repair those, we'll reuse them later, but they actually never got to it just because, when time came they just buy a new cable. So the amount of waste, I mean, a kind of a side benefit to this whole thing is the amount of wasted cables will be reduced. Everybody's got a shoebox. If they're a regular, they've got a shoebox of cables somewhere in their house of
Yeah,
wasted cables that they've had to throw out. So this is a big kind of environmental benefit that's kind of unforeseen from the beginning, I suppose.
yeah, yeah. That's a big thing. Yeah.
Cool. So, and then I think the cables, I've seen some e-marketing you're doing to sell the cables directly online. So, I guess what we could do for you there is we can put a link to that in the comments section or underneath in the description. We put a link to your e-commerce so people can go take a look at what's for sale directly. And I guess anything else that you want to add or any questions from Simon?
Yes. So this is funny, right? This selling of so we are B2C, B2B, right? We try to plug the technology into the factories. That's what we're trying to do, and because we believe that if this could be a new standard, there is no reason why you would not use a JackSavior connector in the future. It's just so much better, and I think if we get the volume up and we can go to stamping and we can do all those kind of things, then there is a cost benefit because there is less material and there is I don't know where we're going with that, but we can definitely match the price, and so I'm really looking forward to that. But the funny thing is that to prototype and to develop such a technology, you need to be in the factories, and you cannot go into a factory without a project. That's not possible. No Chinese will just do anything because you don't have a project. You need to have a project. So
Right.
what you do is that you find a rich person, you ask, can you pay for 1,000 cables, like the MOQ of the factory, and then you will become your own customer. But then what happens is that you place the orders, you buy at the CNC shops, you negotiate with the stamping, and then they say no, that's too low volume, blah blah, but then in the end, you have developed, you improved the manufacturability, you improved everything, and then you have a box of 1,000 cables. That's what happens. So
Yeah.
that's where we felt like, okay, well now, what do we do with the box of cables? So that's when we started
Oh,
doing B2C also, and we to get some upfront sales. Some of those batches were sold instantly. We had one batch that was sold in 2 weeks through Kickstarter. It was just gone instantly, so I could have a good ROI for the guys who gave me the money. So it was or good ROI. I'm not talking about crazy money, but I was able to pay him back, right? And that was the point. And we used it to get the technology to the next point where we can do more implementations. So that's why we have those. And a lot of the products that we made were like batch products. They are all sold out, but we still have the guitar cable left, the gold cable, which is I think the most awesome guitar cable out there for its comfort and its performance. And what we've seen at the NAMM is that you don't have that moment around your guitar, so it won't destroy your guitar, right? And your guitar is your baby, so protect your baby with our cable. That's what it is.
Yeah, no, I'm working on a project with a guy doing a tube amplifier. So maybe we can figure out a way to package your cable with their guitar amp when it's ready to ship.
And
Simon,
I think
you got
it's
anything? I'm sorry.
Amazon US, definitely, Amazon Europe, and those are the platforms where you can find it.
Okay, so we'll put those links in the description for the Amazon stuff. Simon, you got anything to ask before we call it?
No,
a
really
day
good
here?
really good to hear about that, Bouwy. Awesome.
Okay.
Cool.
All right. So thanks, Simon, for joining us with the technical side as always, and Bouwy, thanks so much for getting up early and taking the time with us all the way from Netherlands. You're our first EU guest on our show here, so we really appreciate you taking the time to explain your technology.
Yeah, thanks for having me.
Okay. Everybody have a good day. Thank you. Bye-bye.
Bye-bye.